Hello and welcome to my video 3.4 on Pythagorean Theorem and solving triangles. So first of all, we're going to go ahead and try to solve this triangle here. Just using Pythagoras theorem, we're going to just talking about letters. How do we solve for the different side lengths? Now, Pythagoras theorem is used when you have two sides and we're not necessarily caring about any of the angles in this question. So we often use, we often use lowercase to denote side lengths and uppercase to show the angles. So just like this triangle is listed, that's how we normally will talk about it. Now, solving for side C, another way to say that is the hypotenuse. Okay, to solve for the hypotenuse C, we can use this formula: c squared plus a squared equals b squared. Or sorry, c squared equals a squared plus b squared. So we have that formula there. Now if we want to solve for C, we have to use opposite operators, opposite bedmass. We use this in my class all the time for everything basically. But the opposite of a square is to square root. So the purpose of what we're doing here is because we want to get the C by itself, so we do the opposite of the squaring in order to get the C by itself. So now it equals C equals a squared plus b squared. Okay, this is solved for C now. Now if we look at solving for A, and I'll actually just say quickly afterwards that solving for B is actually the exact same, but if we solve for A, we'll go through a similar but slightly longer process. So if this is what we have to start, and we're trying to solve for A, then our first step is to do opposite operators, opposite bedmass. Now, we can either square root or we can subtract. What happens first in opposite bedmass? Well, we have to subtract first. Okay, exponents happens later, subtraction happens first. So that's why we're going to subtract by b squared first, because we're doing opposite operators, opposite bedmass. So we get c squared minus b squared equals a squared. Now we want to get the a by itself, so now we can square root both sides, just like we did in the last one. The square root and the square will cancel, so we are left with a equals the square root of c squared minus b squared. So we've solved for both C and for A. Now I'm going to just quickly say and show that solving for B is actually the exact same. So you'll notice that we could write it c squared equals a squared plus b squared, or we could write it c squared equals b squared plus a squared, because addition goes either way. Right? You can flip around the different letters and it will be the same meaning. And so from there, we're really going to take exactly identical steps to before, except we're doing it with B. We're trying to solve for B. So now we get c squared minus a squared equals b squared. Now we square root both sides. Those cancel, so we're left with b equals square root of c squared minus a squared. And you could memorize these three versions of the Pythagoras theorem, but I always say don't do that. Don't memorize if you can. Learn the skills. The skills are opposite operators, opposite bedmass. If you can understand that, then you can understand all algebra, not just this single case. So, that's Pythagoras theorem. Now we're going to use that and SOHCAHTOA. So we're going to use both now, okay, in order to solve the following triangles. So what does it mean to solve the triangles? Solving a triangle means that you end up knowing all three sides, okay, and all three angles. So when we solve a triangle, we're looking for three sides and three angles. 3 sides and 3 angles. So what we're going to do is look at the triangle, and we're usually starting with 3 different values. We're always going to start with 3 different values. Now, in this first triangle, it's actually labeled for you. The 90 degrees is one of those 3 values. Okay, but we have 3 values. All of the triangles have 3 values. They're just not necessarily labeled. The 90 is, there, but not labeled in the other ones. It just has the little box symbol, which means the same thing. So we always have 3 things, and we're always going to look for the rest of the items. So let's look at this first one. If you feel like you can solve it right now, go ahead and pause the video, and you could actually solve all 3 of these with everything you know so far. So if you want to pause the video and try it out for yourselves right now, go ahead. Okay, we're going to zoom in and now solve each of these. Feel free to pause between the different triangles as we go. So this first one, we need to solve for the different sides. Now, if we're looking from this angle 40, that makes this side the adjacent, this side the opposite, and this side the hypotenuse. So we need to solve for the adjacent and the hypotenuse. So what we're going to do is we're going to pick the formula that solves for the other side. So in this case, tan of the angle equals opposite over adjacent. So we're going to try to solve for the adjacent side. Okay, so our first step is we're going to have to multiply by a on both sides because we want to get our unknown on top and then by itself. So now it's going to be a tan 40 equals 4. Okay, now what we need to do is divide by tan 40 on both sides to get the a by itself. So we're left with a equals 4 over tan 40, which equals I'm just typing this into my calculator exactly as shown, 4.767. I'm going to leave it there for now. In terms of our final answer, everything is to the nearest tenth in this question, so this is going to be 4.8 there. Okay, the next part of it is we're going to have to find the hypotenuse, and we're going to have to find the other angle. Now, the other angle is actually going to be very easy because all the angles in a triangle add up to 180. So if we go 180 minus 90 minus 40, we're going to get our angle of 50. So that would be 50 degrees there. Okay, and then let's go back down to trying to solve for the hypotenuse. Let's give it a little bit more room. Okay, so we're going to solve for the hypotenuse now, which is going to be, you can use so or ka to solve these. Now, I always recommend using the one that is already known at the beginning. So sine of 40 equals opposite, which is 4, over hypotenuse. So use the number that's already known. So the 4, not the 4.8, so you don't actually accidentally have a rounding error. Okay, now we're going to multiply by h on both sides. Okay, so then we're going to, I want to take it slow. H times sine 40 equals, and these cancel, so equals 4. Now we're going to divide by sine 40 on both sides. Those cancel. So we're left with h equals 4 over sine 40, which equals 4 over sine 40, just typing in my calculator, and we get 6.222, which we're going to round to 6.2. All right, I hope that one helps you guys. We're going to do the next two a little bit faster. So go ahead and pause the video, try it out yourself, and see what you get. Now this first one here is a little bit interesting because we have no angles shown except for the 90. So how do we solve for this other side? I'm going to call it side A. Well, we have to use Pythagorean Theorem. So we're going to solve for side A. So c squared minus b squared equals a squared. Then we're going to square root both sides. So a equals the square root of c squared minus b squared, which gives us here, I'm going to actually plug the numbers in. So 10 squared minus 8 squared, which is 100 squared, or 100 minus 64, which gives 36, and then square root of that, so a equals 6. It's the nearest tenth to be 6.0. Okay, now looking for the angles. I would just, go from one perspective and then call them the opposite and the hypotenuse, and then go from the other perspective and call them the adjacent and hypotenuse. So from the green perspective, so sine theta equals opposite over hypotenuse. Now we have to solve for theta, so it's theta equals sine -1 of 8 over 10. Which is 53.1 degrees. Okay, and then if we do it from the other side, all right, then it's cos theta equals 8 over 10, because now it's the adjacent side. Theta equals cos -1 of 8 over 10, and we get 36.9 degrees. All right. And that's that triangle solved now. We have all 6 items. Now we'll quickly take a look at this last one. Okay. This one here, again, I recommend pausing it before trying it yourself. But let's find the adjacent side first. This is the hypotenuse from this perspective. Okay, so what we're going to do is go cos theta equals adjacent over hypotenuse, which is 7. We're going to move that 7 over, so it's going to be adjacent equals 7 times cos 50. 7 cos 50, which gives us 4.5 once I round it. Okay, then if I'm solving for this opposite side, this is still my hypotenuse here. So then it would be sine 50 equals opposite over hypotenuse. Then I rearrange it to solve for opposite, so I just times by 7 on both sides. So opposite equals 7 times sine 50. 7 sine 50 in my calculator. So I get 5.4. It rounds to 5.4. Yeah, so now that we have the opposite side, we're just looking for one more item, and the way to figure that out is just to double check that you have all three sides, all three angles. So the last one we're looking for is this angle over here, and so all three angles in a triangle add up to 180. So all we have to do is do 180 minus the angles that we have, and we get the last angle. So that's the 40 degrees here. Just a reminder that this is 90 degrees. That's where I got that 90 from. Alright, so I hope this video helps you better understand Pythagorean Theorem and what it means to actually solve a triangle. Hope this video helps, and good luck.